Hello friends, in this video lecture I want to talk about locus of a circle in the complex plane. Let's begin. Locus of circle in the complex plane. Now locus is a very common term that you hear in mathematics, and it's basically relation between coordinates. Okay, see, basically we use different um, planes to define any shape or any trajectory. If I use the Cartesian plane, then I'll see the relation between x and y. Okay, if I use the complex plane, or the argand plane, then I'll see the expression z I, okay, z bar, these kind of things, the variables that are typical of a particular plane. So if you want to write the locus of circle in the complex plane, then you have to use z I, z bar, okay, to write the uh, locus. If you're writing in the Cartesian system, then you have to use x, y, z. It's very simple. So let's begin. So suppose this is the argand plane, real, imaginary axis, and I have a circle which has a radius r and which is centered at origin. So first we are discussing circle centered at origin. Circle centered at origin. So if I take any general point z on the circle, then basically I have to tell you how z will vary on the circle as you move on the circle. As you are moving on the circle, z will change. I have to find a relation that remains constant. That will give me the locus. Basically all the z that are lying on this circle will satisfy the equation. So I have to find one particular equation that is satisfied by all the points. Very simple. Now what to do? The idea is very simple. If I call this as O, this origin as O, and this general point as A. If I want to write OA, OA will be nothing but, we use the same concepts that we have used in vectors. If you want to write OA, and what you do, you're starting from O and going to A. So basically you write head coordinate minus tail coordinate. So head is A, tail is O. So this will be coordinate of A minus coordinate of O. Coordinate of A is nothing but Z. Coordinate of O is 0. Okay, so OA can be written as Z. Okay, now use your mind and tell me what will be the magnitude of OA. Magnitude of OA means this length. This Z is lying on the circle. So whether you go here or any other point, the magnitude of that line will remain the same, which is equal to R. So length of OA will remain same and it will be equal to R. This is the defining quality of a circle. If the length would have been changing, then it will not be equal to R. But since it is equal to R, whether you move to any point, this is the defining property of a circle. So let me write it in general form. OA is Z, so I can write mod Z is equal to R. This is the locus of circle. Locus of circle centered at origin and radius r. So suppose I ask you, what is the locus of a circle which is centered at origin and and has a radius of 3 units, and you will say mod z is equal to 3. If I ask you write the same thing in Cartesian form, then what will you do? If you remember, if the radius is 3 units, the form in Cartesian is x square plus y square is equal to r square. So x square plus y square is equal to r square, so 9. This is the Cartesian form, this is the complex form, and in fact we can go from complex form to Cartesian form also very easily. Z can be assumed as x plus iy, any general point. So mod z will be nothing but x square plus y square under root, and look at the equation, this is equal to 3, so x square plus y square is equal to 9. Okay, so it's very easy to convert from one form to another. So this is the locus of circle centered at the origin. Now circle at some other point. Circle centered at some other point. So this is the argand plane, this is the circle, this is the center, let us say A, this is the origin, and this is any general point B, let us say this is Z, and then I want to find how Z varies. Let me join these 2 points. Now you can clearly see AB can be written as, now this is the head which is B, so coordinate of B minus this is the tail of AB, so coordinate of A, coordinate of B, let us say the coordinate of A is Z1. Okay, so coordinate of B is nothing but Z, coordinate of A is nothing but Z1. So AB is equal to Z minus Z1. So what will be the length of AB? This will be equal to mod Z1 Z minus Z1, and again this will be equal to R, and this will remain constant. As you change Z, the radius will not change. So this is the locus. Z minus Z1 is equal to R. So this represents the center of circle, and this represents the radius. This is the general point. So if I ask you, find the equation of circle centered at 2, 3 and radius of 2 units. So what will you do? The center will be, center Z1 will be equal to 2 plus 3i. So equation will be Z minus 2 plus 3i mod is equal to 2 units. Okay, so we'll continue from here. Stay tuned. We'll meet in the next video lecture. Sorry, and thanks for watching. Have a nice day.